It's lecture time. Let's dive into it.
Topic for today is central tendency measures. Again, this is our statistical circle, and today we're gonna focus around how to summarize my data after collecting and organizing them in a table or by graph. Summarization, this is our topic, and it means to calculate some measures from our data set to represent the data with just one number instead of a graph or a table. And we're gonna cover today the most common measures of central tendency, mean, mode, and median. And also we are gonna talk about two others that are not commonly used, mid-range and weighted mean. And for these measures, all of these measures are calculatable for any quantitative variable, while for a qualitative variable, the only calculatable measure for central tendency, or that will represent your central tendency of the data set, would be the mode. So before introducing the mean, median, and mode and the other two measures, we need to differentiate between two concepts: statistic and parameter. What is a statistic? A statistic is a measure that is calculated from the sample. So if you do have a sample data and you did calculate a specific function or specific measure using the sample data, this is a statistic. While if you did calculate the same measure from the whole data set, the population, then this is by definition a parameter. So parameters are describing population, while statistics are calculated from the sample, and usually parameters are unknown. So what is the mean? The mean is the value of your variable on average. How do we calculate it? This is actually the sum of all the values you have for the specific variable over the total number of the values that you did add. So it's an arithmetic average. And we can calculate that mean from the sample or from the population. From the sample, it is calculated as sum of all the values in your sample over how many value did you add up there in your numerator. Now the symbol for the sample mean is x bar. So x bar is the sample mean. Notation wise, the sum is represented as a sigma. So sum is Latin sigma, Latin letter sigma, and xi is the value of your observation number I among n values, which is representing the sample size. N is representing your sample size. And I can calculate the same mean but from the population. So I will have a population mean, and this is represented by another Greek letter which is pronounced mu, M-E-W, mu, and this is calculated as the same definition of the mean in general, sum of all the values divided by the total number of the values that you did sum. So sum of all the values in your population now, because it's a population mean, over how many values did you have in your population. That big N or uppercase N is the population size, while I am here in my numerator, I am adding still the values xi for my dataset, for each value in my dataset, which are n, because this is a population. Adding these up will give me a value, dividing it over n will give me the value on average for that specific variable that I am calculating the mean for it, whether it's coming from the sample or from the population. And what is xi? Xi is actually a particular observation in my data set that happens to be number I. So I represent the index. If I am calculating it from the sample, it's I running from 1 to small letter n, while if I'm calculating it from the population, so I would run from 1 to capital N, and of course N is the population size, and lowercase n is the sample size, so by definition N should be greater than that one. So after all, I do have a sample mean and a population mean. Each one is calculated in a similar way but using different numbers, and because of that x bar and mu are not the same thing. The second measure is the median, and the median by definition is actually the value in the middle of my data set, and we're gonna use mg to represent it. So median is the halfway point in my data set. How to calculate it? We need to arrange my data from smallest to largest in an ascending order, and after that we need to decide whether my sample size or my population size, depends on your data set itself, is odd or even. If it was odd, then the median would be the middle value among my observation. How? Let me look at an example. We do have here an example 15, 30, 34, 41, and 60 have 5 points, so n is 5, it's odd. The median is the middle data value, so the middle value is 34, which is exactly in the middle of my 5 points, and this is by definition the median. If I did have an even number of points, suppose n, I'm dealing with a sample, and n was even, suppose 6, then I am gonna arrange my values again. I have here the arranged data set, so the two values in the middle, I don't have just one value, I do have two values exactly in the middle of my 6 values data set, and the mean of these by definition is my median. So the median would be 30 plus 34 over 2, which would be 32. So the middle value in an odd set is one of my observations, the specific value in my data set, while if n is even, the median is exactly in between my two values in the middle. It's the average of these two. So the mode, what is the mode? The mode is a value that occurs most often in my data set, and we call it the typical value in my data set or the typical case. And by the way, the mode is a suitable central tendency measure that is calculatable or suitable to a categorical variable. How can we calculate the mode? Well, it's easy. I'm gonna just check what value is having the highest frequency, but I can end up with several scenarios here. I can end up with a dataset that is having no mode just because all of the values are repeated the same number of times, and this is a case where we are gonna call the distribution or the histogram for this dataset to be a uniform shape distribution, and this is the figure that we did see in our last lecture for a uniform distribution, and we said at that time we are gonna consider it of equal, and so all of these bars are of equal height, okay, but theoretical wise it should be exactly of the same height. I could end up with a case where I do have just one peak, so one value is having the highest frequency, and this is a unimodal. It could come when you do have a symmetric distribution, a bell-shaped distribution, or a right skewed, or a left skewed, or a right skewed. Here I do have, as you see, one peak, highest peak, and here as well, and here as well. Another scenario, I could end up with a scenario where my histogram is having two peaks. So like that one. We did see that graph before, and we called that histogram as a bimodal histogram or a bimodal distribution. And the last issue, if I could end up with a scenario where I do have more than two values that are having the same highest frequency, and this is the case for a multimodal distribution, many modes. Now, our fourth measure for central tendency would be the midrange, MR. The midrange is just the average of the lowest and the highest value in your data set. This is the midpoint in your range. So minimum plus maximum over 2. So if you arrange your data from minimum to maximum, the mid-range is exactly in the middle here, which is that one plus that one over 2. It would be that value, the value in the middle. We would like to find the mean, mode, median, and mid-range of a data set. I do have the age of some students. These are exactly 29 students, 29 observations. And we want to calculate mean, median, mode, and mid-range. So let we go and calculate it. So let we calculate the mean. Here we did have 29 observation, 29 people or student. This is a sample. So the mean is X bar, and I'm gonna add all the values of my ages, the 29 age, and divide it over the 29. So adding 19 plus 23 till the end of my data, till the last one, over 29. These are equal to 603. So 603 over 29 would give me 20.8. So the age value on average, the age variable is taking on average the value 20.8. This is by definition the mean or the average for short. Arithmetic average, of course, but for short it's average. For the median, we need to decide whether n, or the number of our observations in my data set, is odd or even. It's 29. This is an odd number, so the value exactly in the middle of my ordered array of these 29 observations is by definition the median, the middle value. So how can we come at that? Well, I'm gonna after ordering it from smallest till highest, I'm gonna cancel one from top, one from bottom, one from top, one from bottom. Doing that, you will end up with just one observation on its own standing exactly in the middle, which is the 21. So the median is 21. Another way to come at the same value is to take your n divided over 2. It's gonna give you 14.5. This is not a possession, so round it up, it would be 15. So the observation in possession 15, after ordering them, of course, would be your median, which is the 21. For the mode, we need to go ahead and see which observation is having the highest frequency or did appear the most. Here 17 appeared, 18 appeared, 1, 2, 3 times, 19 appeared 5 times, 20 appeared as well 5 times, so we do have 19 and 20, the highest one till now. 21 appeared 5 times, and 22 appeared less than that, 23 less than that. So we do have 3 values. They have the highest frequency, which are 19, 20, and 21. These are our modes, so it's a multimodal scenario. I could have reached the same values if I did create a frequency table. So I'm gonna take the 17 is my smallest one. How many times did I find 17 in my data? Just one. So the frequency of 17 is 1, frequency of 18 is 3, 5, 5, 5. and the remaining. So just I did create a frequency table for that small data set, and I'm gonna pick these values of my quantitative variable that are having highest frequency. Mid-range is the value exactly in the middle of my range of the data. The data range is taking values from 17 to 25, so the mid-range would be 17 minimum value plus 15 over 2, it is 21. So median, mid-range, and sample mean is about 21, but I do have here 3 values for the model. The last measure of central tendency that we are going to cover is what is known by the weighted mean. Sometimes the observation in your data set is not having the same weight, so each value is weighed differently. In this case, we are going to say that I do have a weight for each variable x, each value x of my variable x, and to calculate the mean, I need to take that into consideration. How to take it into consideration? I am going to calculate the weighted mean as the sum of the weighted observation, which means multiply each observation x by its weight first, and then sum these together and divide over the total sum. So again x bar, but instead of just adding xi on their own, I'm gonna first get the product of each xi, each observation times its weight, add this up, this is your numerator, divide over the total weight. Okay. A good example for the weighted mean is the GPA. So assume we do have a student who got an A in English, and English course is 3 credits, C in Intro to Psychology, 3 credits again course, and 4 credit course which is Biology, that student took an B in it, and G in Physical Education, which is 2 credit course. If we are gonna go with a typical grading scale, A is 4 points, B 3 points, C 2 and G 1 point, while F is 0, of course, point. So the GPA for this student in this specific semester is nothing but the weighted average, where the weight is the number of credits and the points GPA, the point is 4, 3, 2, 1 for the ABCD grade. So the grade ABCD, the value point or the scale was 4, 2, 3, 1, and these are my courses, and these are the credits of each course. Doing that, putting all of my information in such a table will ease it on myself, because the GPA is nothing but the x bar weighted mean. So I'm gonna calculate it as 4, my x times 3 plus 2 times 3 plus 3 times 4, 1 times 2. It's gonna give me 32 over the total number of my weight, which is 12. So that student in this semester has a GPA 2.7. So let we have a comparison among mean, median, mode, and mid-range. How many observation is used to calculate each one of these? For the mean, we are adding all the observations to calculate it. Median, we are just using either 1 or 2, depends on whether your sample size or population size was even or odd. Mode depends on, well, whether it's unimodal case, no model case, unimodal, or so on. Mid-range, just 2 observations, the minimum and the maximum. The uniqueness, well, the mean is calculated as a unique value. Median is also a unique value, regardless whether it's just one value or the average of 2 values, but still it's just one value, unique value for each data set. The mode could be more than one, could be unique, it depends. Mid-range, a unique value. Affected by outliers. So outliers, as we said last time, it's either a very small observation or a very large observation. So since the mean is using all the observations in my data set, if one of my data set is an outlier, the mean would be affected. For the median, does not matter because we do arrange the values, and the median is a value in the middle. Outliers are in the two extremes, too low or too high, so the median is not affected at all. Mode will not be affected. Why? Because the mode is the most frequent point in your data set. So even if that value was the first value in my data, the smallest one, because if it is a mode, then it's gonna not be at all an outlier, because outlier is a value which is too far from the remaining of or the bulk of your data in your data point in your data set. So it's gonna not be affected by outlier because mode again is the typical value, which means it is appearing the highest number of times in your data set. Outlier would be rare ones, so not the mode. Mid-range, obviously, yes, if we do have outliers, it's either the minimum or the maximum or even both of these, so it is affected. So mid-range and mean are the two central tendency measures that are affected by outlier. What does it represent? Again, as we said, the mean is representing the value of your variable on average. The median is the middle value of the data set, the value exactly in the middle, where half of the point above it and the other half below it. The mode is the typical case or typical value in your data set, that value that is most frequent. Mid-range is the midpoint in your range. Which one is the easiest to calculate? Obviously, mode is the easiest one, no calculation at all. Second one would be the mid-range. Identifying the shape. I can use the relationship between mean, mode, and median to know what is the shape of my distribution, and vice versa. If I know the shape of the distribution, I can say something about the relationship between mean, median, and mode. How? For that histogram, if my histogram was bell-shaped, then mean, median, and mode are at the same point here, so they are all equal. If I had a right skewed distribution, then the class with the highest peak is your mode. The mean is going with the outlier. As we said, it is affected by outlier, so it's going with the tail. So if I do have an outlier, it would appear here with the bar, which is having maybe the smallest frequency somewhere here. So it is usually going with the tail, and the value median is the value in the middle, so it has to be in the middle. So if you do have a right skewed distribution, mean greater than median, and the smallest one would be the mode. Or if you have a data set where you did calculate mode, median, and mean, where mode is small and mean is the biggest one, higher than the mode and median, then this is a right skewed distribution. On the other hand, if you had a left skewed distribution, negatively skewed, you would have the relationship reversed. So this means the mode is always the peak, which means following the crowd, highest frequency. Median would be always between my two measures if I am not a symmetric distribution, and the mean goes with the tail if again I am not a symmetric distribution. So we begin our first activity. We do have 5 distributions, and we would like to determine the relationship among my 3 measures of central tendency, mean, mode, and median. So in the first graph, I do have here a symmetric unimodal distribution, bell-shaped. I do have one peak, so this is my mode, and because it's bell-shaped, I will have mean and mode median at the same value. For the second one, I do have here what is known by the uniform distribution. It's a symmetric distribution. Why? Because if you put here in the center a line, a mirror line, you will find out that the left hand side of your curve is exactly mirrored to the right of your line, so a symmetric distribution. And in a symmetric distribution, the middle value would be exactly in the center, which is your median and happens to be also the mean. But I don't have here a mode because there is no single value which is having higher than the remaining points under the curve, higher frequency, so this is a no model case. The third graph is having a tail to the left, so this is skewed to left actually, and I do have still one peak, which is the mode, and since I do have a long tail, the mean is going with that long tail as we did discuss a couple of minutes ago, and the median would be in between, so mean less than mode and less than median. So mean less than median, less than mode. Here is the opposite scenario where the long tail is to the right, and I would have mean the greatest value and mode the smallest value. Still the mode is here and the median is between mean and mode. The last graph is having two peaks, so I am in a two model case by model, and it is symmetric because if I put here my mirror line exactly in the middle of the range under that distribution, you are gonna find out that the left hand side is exactly mirrored to the right hand side. So this is a bimodal and symmetric case, roughly. Let me say roughly because I don't, yeah, roughly. And in this case, I have mode number one less than mean, where the mean is exactly equal to the median, and less than the mode 2. Again, assuming that this tail is exactly the same as that one. How many modes? Here one mode, one mode, one mode. So for any unimodal curve, whether it's symmetric or not, I do have one mode. Uniform has no mode at all, and in a bimodal by its name I do have two modes. So as we said, the name of the shape, this is bell shape. I can also call it symmetric uniform model, and here I do have the left skewed distribution or negatively skewed distribution, here a right skewed distribution or a positive right skewed positive distribution, positively skewed distribution. This is the bimodal and this is the uniform. And as I said, bell shape is meaning symmetric and unimodal. However, symmetric alone will not guarantee unimodality because uniform is symmetric. Bimodal, this one is symmetric, but I don't have a unimodal. Our last slide or our last activity would be that one, airline safety violations. We do have 20 administrative actions that represent 20 observations that represent the type of violations for administrative actions. And what SS security, M maintenance, F is flight operation, and H is hazard materials or others, various other type of violation for 20 administrative action again. And our question, the first question here is, what is the type of the variable? Well, the values of my type of violation is categorical, just letters. So this is a categorical variable or qualitative variable. What is the level of measurements? Well, we said qualitative variables are measured either on the nominal scale or ordinal scale. And since I cannot have here any order, I don't have an specific order for whether S is better than M or M is better than S, no order. So this is a nominal scale. What is the suitable graph to represent this data set? If I am gonna represent a categorical or qualitative variable, it is only pie chart or bar chart according to what we did cover. The suitable measure of central tendency, it's a categorical variable, so I cannot use the mean, I cannot calculate the median, so it is only the mode. So I would count each category, how many times each category did appear, the frequency of each category, and the mode would be the one with the highest frequency, and it turns out that this is the S, which is security type of violation. So this is the end of our lecture.